Hi everybody, I'm Miss Groth. Today we're going to talk about one of the most important things in biology, which is homeostasis. Homeostasis is how the inside of your body tries to stay the same even if things outside of your body change. So right now, at this moment, your heart is beating at exactly the right pace. Your lungs are making you breathe at exactly the right pace. Your body temperature, unless you're running a fever, is exactly 98.6 degrees Fahrenheit. Your blood glucose levels, like how much sugar there is in your blood, those are being regulated. And all of these things are things you don't even have to think about. That's homeostasis. So, I'm going to give you an analogy for how homeostasis works. So, think of your body like a house, okay? Inside the house, you've got a thermostat running. It's 72 degrees inside the house, okay? If it's 72 degrees outside, 72 degrees inside, perfect. But let's imagine that it's a hot summer day, like one we had like last week where it almost hit 100 degrees, okay? What do we think is going to happen to the inside temperature of your house with your thermostat set at 72 degrees? Is that temperature going to change? Is it going to go up? Going to go down? It's going to stay the same, okay? It's going to be 72 degrees inside that house no matter what, okay? Even if it's 20 degrees below freezing, okay, the inside of your house is going to be 72 degrees Fahrenheit because that's what you set it at. That's how your body thermoregulates or regulates your body temperature. It's going to keep the same temperature inside your body no matter what's happening outside. That's why we do things like we sweat to cool down or we shiver when we get cold because your body is trying to maintain that internal temperature. So if you think about it, homeostasis is kind of automatic. Like you don't think about shivering when you get cold. It's just something that happens. Nobody likes sweating. It's just something that happens. So homeostasis works mostly in the form of feedback mechanisms. So feedback mechanisms are your body's way of responding to changes outside. So for example, on a hot day, okay, the temperature outside sometimes gets hotter than the normal human body temperature. So normal human body temperature is 98.6 degrees Fahrenheit, as shown by my stick man right here, okay? If it is 100 degrees outside, that is hotter than 98.6, right? Because it's a bigger number. So my outside temperature is going to be something I call a stimulus. This means that it is going to stimulate, keyword, stimulate a response in my body, okay? And there's a few different responses that can happen, but we'll just focus on one. So your body is going to act as a receptor. It's going to receive changes that it senses outside. So the human body is going to be the receptor, and the receptor is going to send a message to the brain or the control center, okay? So my brain is the control center, and my control center is going to say, okay, how can I fix this problem? We can fix this problem by sweating. Okay, this is going to be called an effector because it is the effect that the stimulus has on the body. Okay, so I'm going to sweat. I'm going to get all gross and sticky. I know, it's awful. And then once my effect happens, I'm going to go back to my receptor, and my receptor is going to tell me, okay, is this doing enough? Do I need to do more? Am I still too hot? And it's just going to keep going in this cycle until you are 100% guaranteed to stay at this 98.6 degrees Fahrenheit. So this is something we call negative feedback. Negative feedback does not mean something bad. Negative feedback just means that we don't like the change that happened outside, so we're going to try to cancel it out. So negative feedback is how the human body regulates most of its functions. So temperature, negative feedback. We don't like it when it's too hot. We don't like it when it's too cold. Blood glucose, we don't like it when it's too high. We don't like it when it's too low. Water levels, when you eat something super salty, your body gets super thirsty. Okay, that's an example of a negative feedback. So there's another type of feedback called a positive feedback. And just like with negative feedback, positive does not always mean good. So positive feedback means that we have a change and we want the change to keep happening. So there aren't very many examples of this in humans, but one of the big ones is like in childbirth. So the human body, when it's giving birth, will naturally produce a drug called Oxycontin. Okay? Oxycontin is, it's not, but one of the most common examples that we see in biology is during childbirth. So during childbirth, the brain will naturally produce a drug to relieve the pain. And childbirth is super painful. So obviously we want that pain relief. So your body is going to sense that it is in labor, and it's going to produce this drug, and then as your labor progresses, it's going to produce more of this drug, and then more of this drug, and then more of this drug. And that's kind of one of the more common examples of a positive feedback mechanism in humans. So to make it a little easier to understand the difference, I drew a little diagram. So as you can see, they have all the same parts. Okay, we always start with a stimulus, and then our body needs to receive the stimulus, and then this, whatever signal we received is going to go to the brain or the control center, and then this brain is going to send a signal to an effector. Your effector is anything that makes a change based on the stimulus. So in the case of a positive feedback mechanism, our effector is going to increase the stimulus. Okay, so with my example with childbirth, okay, the release of this pain relief drug is also going to increase how far along the labor is. Another example for a positive feedback mechanism in humans is blood clotting. There's lots of positive feedback mechanisms in plants, but there aren't a lot in humans. For negative feedback loops, we're going to have a receptor that's going to react to a stimulus, just like we did with our positive feedback loop. We're going to have our receptor respond. It's going to send a message to the brain. The brain's going to send a message to whatever needs to get the message. And it's going to try to decrease the effect of the stimulus. So the human body loves using negative feedback mechanisms. So we use negative feedback for temperature, for our blood sugar, for our breathing. Your body can detect how much oxygen and carbon dioxide there is in your body. So it can detect all of that and make changes based on that. And it also changes based on hydration. So for hydration, there's a few things that we do. Maybe if you're overhydrated, you really have to go to the bathroom. If you're underhydrated, you get thirsty. You have like a hard time sweating, which also makes it harder for you to cool down if you get too warm. So all of these things that our body balances, they all need to be perfect. Otherwise, it can mess with other systems, as seen with the hydration and the temperature regulation. So temperature regulation, very simple. If it's too hot, you got to cool down. If it's too cold, you got to warm up. And there's a few different ways that our body does this, which we'll talk about throughout this module. Blood sugar levels. There's different organs in the body that release different hormones, depending on whether your blood sugar is too high or too low. So for this unit, we're going to focus mostly on humans, but there's a few things that plants do too. Have you guys ever heard of sunflowers and why they're called sunflowers? So when a sunflower detects sunlight, it's going to take the front of the flower, the part that collects the sunlight, and it's going to turn it towards the sun. So plants also respond to their environment, which we're going to touch on a little bit, but we won't really focus on it very much for this module. So I look forward to seeing what you guys submit at the end. Let me know if you have any questions in the Ask a Question forum.